Hello everyone, welcome to AI Anytime channel. In today's video, we are going to see that how we can deploy a large language model on AWS SageMaker. So if you are not familiar with AWS SageMaker, it's a machine learning platform that helps you create, train and deploy machine learning models. Okay, it was launched by AWS I think 5 or 6 years ago. Okay, so we are going to leverage SageMaker's capabilities to deploy this large language model. Okay, the reason being because most of the time you might have been working on some cloud platforms or the hyperscalers. So how can you deploy a large language model on these hyperscalers, starting with AWS, because AWS being one of the most prominent hyperscalers that a lot of clients uses it, right? And eventually we'll also see how we can leverage GCP Vertex AI and Azure machine learning platform to deploy large language models in the coming videos. So I'm trying to here create a few of videos on the hyperscalers and how these models can be deployed, for basically for your clients and also for the enterprises, right? If you are building an enterprise grade solution, how you can spin off an instance and deploy these large language models, create a lambda function and invoke through an API endpoint, right? How we can follow this step end to end, and how we can deploy this model so you can integrate this in an application, right? That's what we are going to do here. So any model which is available on Hugging Face, okay, you will be probably able to deploy on SageMaker, and there are around 14 to 15 base model, and of course there are variants like quantized models and the other variants on top of that base models. They have a very unique and a new uh, service that AWS has basically created, that's called DLC, that basically works with the Hugging Face model. So you can very easily deploy Hugging Face based model on AWS SageMaker using that DLC. There's basically a lot of images that they have created in ECR. You can just use those basically from AWS, and you can just deploy that model in a few minutes. That's what we are going to explore in this video, guys. We'll take a model from Hugging Face, we'll spin up an instance on SageMaker, and then we'll go and deploy, and then we can also invoke that through Lambda, right? So that's what we're going to do here in this video, guys. So let's get started. So if you see, currently I am on AWS console. Okay, you can see the console AWS amazon.com. Okay, I am in Ohio. Maybe we can look at some other version. Let's keep North Virginia for example. Okay, so if I do that, that's how you basically find the versions here. You can see the region. Okay, these are the region that we have. Okay, Oregon, California, and in Asia we have most probably the data centers, that if you use this region, your data center will be located into this region itself. So that's the first step. You can see it's my personal account. Okay, so I am on a personal account currently. I'm going to explore that how we can use these services. So you can see I have some services over here: IAM, EC2, S3, RDS, Lambda, right? So this is the first time I'm creating a video on any of hyperscaler, but I will create some videos on Azure and GCP as well. So the first thing that we have to do, meanwhile, we have to search for SageMaker. So let me just search for SageMaker, and you can see here we have something called Amazon SageMaker. Build, train and deploy machine learning models. That's what we are going to do in this video, guys. Let me click on SageMaker. I'll do a right click and open it, and I opened it. Or maybe I can just start this. When I start this, you can find that SageMaker. So basically what happens when you're using this cloud, right, the hyperscalers, you will probably use a lot of services regularly. For example, S3, right, S3 bucket. You can also start those here, and you'll be able to see it right there. So you don't have to search every time. You can just click that. Basically works like a bookmark. Okay, now if you come over here, it says Amazon SageMaker, build, train and deploy machine learning models at scale. Okay, and you have some documentation how it works and a lot of other things, right? So what we have to do here, if you come on the left hand side, we are interested in notebook, because we'll spin up a notebook instance, and then we'll start writing code. and we'll see how we can deploy the model, and automatically we'll see that how DLC will help us, on the inference part when creating an endpoint right from SageMaker. That's what we are going to do here, guys. So let's do that. So what I'm going to do here, to click on notebook instances. Now when I click on notebook instances, you can see currently it says there are currently no resources. Let's create a notebook instance. Now when I click here, you will see a different types of notebook instances type. Okay, so let's come here and use, for example, maybe I'll use compute optimized, and I will use MLC5 2x large. Now you can also do one thing, you come here and say MLC5 2x large. They will show the Amazon SageMaker pricing. Go here in the SageMaker pricing and you can find it out. So I am using, for example, MLC5 2x large instance. It's 8 CPUs. It has 8 CPUs and it has 16 GB of memory, which I feel that I will take a small model just for this demo purpose. I'm not going to use Falcon or MPTs or Llama, for example. I'll take a smaller model in parameters and I'll just show you the process end to end. Of course, the process remains the same. You just have to change the backend when it comes to trying different models. Okay, so I'm going to use this machine, MLC5 2x large. But if you are interested, you may look at some other machines like G5, mainly G4DN and G5 machines. If you really want to run Falcons and MPTs, right, you can use these instances. Maybe this is very famous, ML4 G4DN 12x large, and also this number of GPUs when you want to use 4 GPUs there. So let's use this C5 2x large. I'm just going to give a name here. I'm just going to call LLM experimentation. LLM experimentation. Okay, and this video will help you guys. If you are basically working at some workplace that basically where they demand and they ask you to deploy models on AWS or any other cloud hyperscaler that we have. So it says choose an IAM role. I'll say use existing role or create a new role, for example. So let's say any S3 bucket, it's fine. Okay, S3 bucket you specify. So you have created an role, you can see. Okay, but you can also give some custom names and all. Okay, so let me just do one thing. You can see your notebook instance is being created. Okay, so it will take a little time to create that. You can see it's pending here in the status, and we have this instance, and our instance name is LLM experimentation. Now if you come over here, this is the model we are going to take, guys, Lamini T5738. Okay, and which is fine-tuned, okay, on T5 large. You can see the model is fine-tuned version of T5. Okay, T5 is very underrated language model. I think T5 was created by Google. Please let me know if I'm wrong there. Okay, so this model that I'm going to use, because I also have a lot of videos. Last 2 videos has been on Lamini T5738M. The reason being, it works fine for a lot of use cases like code generation. You can generate, when I say code generation, it's text to code, okay, instruction based models, and it also works fine with question answering. One of the best model I have seen for question answering and summarization, to be honest. Okay, if I talk about the smaller language models, okay, you can consider using Lamini T5738 million parameter model. You can go through this video, guys. I have created this couple of videos which is like training this LLMs, or fine-tuning, basically not training, fine-tuning with help of these embeddings that we create using Chroma and stuff. You can basically create a question answering tool. That's what we have created here in this, and in this one we have created a chat bot, okay, with Streamlit chat. So you can consider watching that videos if you are interested and want to create something similar. Okay, now in this notebook instance, let me just do, maybe you can click on view details to see, and it will show you. Okay, it's currently in pending notebook instance, and you can find a lot of other things here as well. You can connect your Git repositories and all as well. Okay, so let me just go back on the notebook instances. It's pending, and this is the model we are going to set. So what we will do, guys, right, in this video, when you click on deploy on most of the Hugging Face spaces or the models repositories, you will find a lot of options how to deploy this. Okay, now if you see Amazon SageMaker, when you click on this, you will see the deploy.py code, right, which is on SageMaker, which uses SageMaker SDK. if you see this is the same thing that we are going to use here, guys. Okay, yeah, in this video, but we will make some changes, not the exact same thing. There will be few changes, right? How we can use this Hugging Face LLM image URI. That's what we're gonna do here. Okay, we're gonna explore. Let's do that. Okay, it's taking time, and you can again deploy Falcon 7B. If you want, you can see Falcon 7B. You can click on deploy SageMaker. It works the same way. Your instance will be on little on the higher side. Okay, you have to take a better machine because it's a compute heavy model, right? So for that you have to take a bigger machine on SageMaker, but you can deploy Falcon 7B. It works perfectly fine. I'm gonna focus on Lamini LM and then see how I can create basically an API endpoint that I can use it in my application. So if I come over here, let me just go to notebook instances. You can see now it's in service. So what I will do, I will open a Jupyter lab. Okay, and in this Jupyter lab I will start writing my code. We will try something. Okay, in this Jupyter notebook we'll first see if we are able to basically use Lamini LM, see if it's working fine, and then we'll go on deploy it. Okay, so let's do that. So it will take a little time to open up, and it's opening, and you can see in US East 1 SageMaker AWS/Lab. Okay, so let's see that. So here you can find all the details, guys. Amazon SageMaker pricing. I'll give the link in the description, but you can also find it on of course on internet. So you can see I am on Jupyter Lab. I prefer Conda PyTorch default notebook, which is having Python 3.10. 3.10 is the best version to work with language model. Okay, so in my last few months of experimentation, both individually and at the workplace for clients, I have came across that Python 3.10 works the best, because we have to work the way of with libraries like accelerate, bits and bytes, shape tensors, etc., which supports 3.10. Most of the time it works completely fine. So I'm just gonna use Conda PyTorch 3.10, which has Torch installed by default. Okay, and I'm just gonna let me rename it. So let's rename this and call it LLM trial or something like this. Okay, I'm just gonna rename it. Now once I rename it, let's do a couple of changes here, guys. So I'm gonna go in settings. I prefer a dark theme. I'll just make a dark theme here. I'll also increase the font size. So let me just increase the font size one more time. You can also set it up through NB extensions and all, but I'm just not going to do that here. Increase code font size. So let's first install a few of the things, libraries that we need. So the first is pip install. What we need is transformers. The first thing that we need, EINOPS, and we need accelerate, and then we need bits and bytes. So I hope I spelled it right. Transformers, EINOPS, accelerate, bits and bytes. Now let's basically install these libraries. So you can see that I am installing these libraries. Pip install transformers, EINOPS, accelerate, and bits and bytes. That's what we need, right, guys, to work with. Accelerate will help us inference these bigger models, and you can see it's installing. You can also see it here, and you can also see it will say kernel is busy. Okay, the kernel status. Okay, basically if you have worked with Jupyter notebook, it's a Jupyter notebook inside the SageMaker instance that we are using. It's the same thing. Now let's import all the things that we need. So the first thing is from transformers. So from transformers, import auto tokenizer. I'm gonna use auto tokenizer, and I'm also gonna use auto model for sequence. So auto model for sequence to sequence LM. That's the first thing that I'm gonna need. Maybe you can also take it from here, guys. Let me see if they've given the code base. I'm not gonna use through pipeline. Okay, so let's write our code here. Okay, so the first thing is from transformers, import auto tokenizer and auto model for sequence to sequence language model. Now the next thing is the pipeline. So from transformers, we're gonna use the text to text generation pipeline. So pipeline. From transformers, import pipeline, that we need torch, so import torch, and we need base 64 for example, so let's add base 64. Let's now run this. Invalid syntax, auto tokenizer, okay, I have forgot to give the comma there. Now it will import it. Now let's write the next line here. I'm gonna do checkpoint here. So the checkpoint is nothing but my checkpoint remains this Hugging Face repository, from where I will just pull the model weights. Okay, so let's do that. This is my checkpoint, and I'll also add few more lines of cell here. The checkpoint has been defined. Now let's write tokenizer and base model kind of a thing here. So tokenizer, and then we write auto tokenizer. So this is how it goes, auto tokenizer and auto tokenizer, and then in this basically from pre-trained, so we are getting it from pre-trained, and from pre-trained, and you can see this has been imported. Now let's run this checkpoint. I'm just gonna pass the checkpoint here, guys. So checkpoint, so this tokenizer is done. Now we are using checkpoint. You can see from pre-trained. Now let's have a base model. So our base model is the Lamini model that goes with auto model, auto model for sequence to sequence, and inside this is what I'm going to do, guys, like auto model for sequence to sequence, and let's sequence to sequence lm dot from pre-trained, and you can see that from pre-trained by IntelliSense. Let's pass this, checkpoint and device map and kind of a stuff. Checkpoint, so let's keep checkpoint, and then we have device map. I'll keep device map auto. Let's define some of the basically offload some of the weights to CPUs, so I'll keep it auto. Okay, device map auto. You can also use device map equals CUDA if you have high compute power and it has a CUDA kernel there. You can do device map equals to CUDA, and you can also do device map CPU if you have, I can do that CPU because I have 8 CPUs there, but you can also do that. You can explore it completely, right? So I'm keeping device map auto. It will automatically offload the weights. Okay, so device map auto, and then I will also have torch D type. Okay, the data type for this torch tensors. So torch D type, and my torch D type is nothing but the torch dot float 32. I'm just gonna use the float 32. You can also use float 16, but here I'm trying to save some of the compute power, guys. Okay, so checkpoint, device map auto, torch D type, torch float 32, and this will take a few minutes because it has to pull the weights, guys. Let's do that. You can see now it's downloading the PyTorch model, which is around 2.95 GB. Let's let it download. Let's write the function, guys. So I'm just gonna use LLM pipeline, or can I also get it from my GitHub repository? I don't want to write a hell lot of code there, but my focus is on deployment currently. So let me come back, and I will take the code from one of my GitHub repository, one of the videos that I have created where I have used Lamini. So let's take from app.py. I'm just gonna use this define LLM, okay, pipeline kind of a function, and let me do that. So I'm just gonna paste it over here, and you can see now what we are doing here. Let's see that. So we have top 5 local LLM and return. So this looks nice. So this is a pipeline that we are using, guys. Text to text generation. If you want to use summarization as well, you can use summarization, because a Lamini LM has a summarization pipeline as well. Okay, so if you want to create an application where you want to generate summary from your documents or from your text, basically text data, you can do that as well. So let's do that here. I have defined this function LLM pipeline, and just what I'm going to do here is I'm going to write an input prompt. So let's do that. So my input prompt, and I'll say, okay, write an article on generative AI, or let's write on first on artificial intelligence. Now this is my prompt. Okay, input prompt, write an article on artificial intelligence. It's not a prompt. I'm not following any prompt techniques like zero shot or chain of thought. If you want, you can do that. Okay, so let's use this input prompt where I have defined. Now let's use that, guys. So I'm just gonna do model equals LLM pipeline. So LLM underscore pipeline here, guys, LLM pipeline, and inside this I'm just gonna my model will now be assigned to this model variable from LLM pipeline, and now I'll have a generated text variable which will hold the generated text from the model itself. And here we'll do model and input underscore prompt. So let's do that, and then we have generated text, generated underscore text. So let's run this and see if we are getting any error or if it generates some response. And you can see it says Hugging Face pipeline is not defined. Okay, Hugging Face pipeline is not defined. Okay, so okay, let's load this from LangChain, for example. Okay, so we can load that from LangChain. Let me add it from here. But for deployment we don't need that, but because I'm loading it from Hugging Face pipeline, because I think that will help us create chains. And also, just for this video quickly, I just install it from LangChain. So pip install LangChain, and it will install the LangChain, and then I will import. After this, let's wait for it. So what I was going to do here is, after this I will just add, and I'll just say from LangChain.LLMs import Hugging Face pipeline. Okay, Hugging Face pipeline, and I think I have made a typo here. That should be caps. Hugging Face pipeline from LangChain.LLMs import Hugging Face pipeline, and now this should work. Let's see. So guys, the reason why I'm also trying to bring the LangChain element, because in the coming videos, because I'm also working with Azure machine learning, and right now you are seeing AWS here. Maybe we'll also see that how we can basically bring LangChain framework with these LLMs on hyperscalers. Okay, deploying a model is easy because they have given the code, but how we can use this framework is something that that's the agenda for the future videos, guys. So you can see that this is an article, that the response that we have got, and fantastic response. Okay, and artificial intelligence is a rapidly growing field that aims to create machines that can perform tasks, blah blah blah. So we have got a response. So this is what wanted to show right in this video, guys. So now what we will do, we'll see that how we can deploy this. Now for deployment, the first thing that you have to do, update the version of SageMaker. Okay, that's what we first have to do, guys. So let's do that. So what I'm going to do, I'm going to first uninstall this and install SageMaker again. So pip uninstall. I'm going to do y, okay, like SageMaker, pip uninstall, and y SageMaker. Okay, so let's first uninstall the SageMaker, because we need a specific version of SageMaker, because most of the time when I was trying it out, I got errors while the deployment, because it says that it cannot, the issue was with the Hugging Face image URI, okay, the LLM image URI. You can see now we have uninstalled. Now we'll install SageMaker, guys, again. So let's do that, and the specific version of that. So pip install SageMaker, and this goes 2.168 not. Okay, this is the version that we need for SageMaker for the deployment with this DLC and image URI that we have. So this is what now we're gonna do. So let me just see that on my monitor, 1 second. Yeah, so what we're gonna do here, let's take this code snippet and see what are the things that we can change. So when you come on SageMaker, you can click on copy, come here, paste it over here. Now you can see when I pasted it out, what we are doing, we are importing JSON, we are importing SageMaker Boto3, and this is what the interesting thing, get Hugging Face LLM image URI. Okay, so and then we have execution role, Boto3 client, blah blah blah, and let's do that. So here we will define a few things. So you can see that this checkpoint has already been defined, because we have taken from that Hugging Face repository, but we are not going to use any number of GPUs here, guys. So I'm just going to remove this, because we are not going to use any GPU. Okay, but maybe we can use that, we can have that, but it's not required. So what I'm going to do here is HF task. What the task that we are going to use, Hugging Face task, the task is text to text generation, right? So text to text generation, this is the task that we're going to use. And the next thing that we have is device map. We can define all this config here. So device map, and here it will be auto. My device map is auto, and the next thing is torch d type. So let's do that. Torch underscore d type, and this torch underscore d type is nothing but the torch dot float 32. Okay, this is what I want to do here. So this is what the hub. So hub model configuration. So to Hugging Face model configuration, how you're going to load the model. Here you can configure all these things. So model ID, task, device map, torch d type. Okay. Now if you come down, you will see the Hugging Face model, get Hugging Face with the versions and all. This is completely fine. We're not going to make any changes. Now in the predictor, we have this G5. So let's change this to G4DN, which has a CUDA kernel. Just for your information, if you want to deploy through this DLC, the new feature of SageMaker for Hugging Face models, you need a CUDA kernel. Okay, that can be any CUDA kernel. So I'm just going with G4DN for now. But for deployment, it needs a CUDA kernel in backend, right, to basically handle your computation there. Okay, so ml.g4dn.2x large. Okay, so I'm not going to use 2x large. I'm just going to use x large here. So instance type ml.g4dn x large. Okay, and you can see this timeout 300. That's okay. I'm not going to remove that. So in input, let's remove this and say, for example, write an article, short article, write a short article on blockchain, something like this, blockchain. Okay, this is my thingy here. So predictor.predict, this is the predictor.predict class, sending request, and this is basically the deploy class. You can see Hugging Face underscore model.deploy, that deployed, total instance count, so one instance type is ml.g4dn.x large, and then we have container restart type health check timeout, and then we have this models and hub. So this is simple. This will basically configure the endpoint for you, and this will automatically create the endpoint for you guys, model endpoints, and that you can find it over here. So let me just go back on here in Friends, and you can see we have two things, endpoint configurations and endpoints. But this will basically configure the endpoints, and also it will create the endpoints for you, the model endpoint, and then you can create a Lambda function to basically use that and test it out. So this is what we are going to do, guys, in this one. So let's do that now. So yeah, so it's okay. Now let's run it and see if we are getting any error, guys. So you can see it's currently running. So it will run. It will take little time, of course, to basically create the infrastructure for you. Okay, you do not have to do anything. It will automatically be created, and your model endpoint will be created, of course. Okay, so they will configure it and then automatically create it for you. So you just have to define it over here. And the same way, you can also do it for Falcon and MPT and any other model as well. So let me just see MPT7B by Mosaic ML, and Mosaic ML has been acquired by Databricks. I hope you're aware about that news. And you can also use MPT7B. Okay. Now you have a lot of other models like Star Coder, for example. Star Coder. And you can also deploy that. So click on SageMaker and deploy it over here. So you can also do that in that case. You can now see, you can see a loader there. It means that your model is getting deployed. Okay, and the endpoint will be available very soon. But let's wait for it. It will take a little time. So what I'm going to do here, guys, I'm going to stop this video and come back once it is done. Okay. So you can see, guys, right, we got the response here now. Generated text also. Blockchain is a decentralized digital ledger that records transactions in a secure and transparent manner, right? And if you see, the model has been deployed. Let's go here on this notebook instance, come to these endpoints. Now when I go on endpoints, you will see a model right there. Okay, model endpoints, by the way. So if you see, it says Hugging Face, PyTorch, TZL, inference, and date, and the IDs, the ARN, the creation time. If you click on that, it will show you some more details about it. okay, the monitor and all these details that we have typed, URL, etc. So we have an endpoints now. Okay, now what we will do, okay, you can see the response. You might say, hey, I only got one line, because we have to basically use the other parameters basically to generate a lengthier response. So let's do that in that case. So what I'm going to do here is I'm just going to define a payload. So let me first define a prompt, and my prompt is, for example, uh, uh, write a short article on blockchain. The prompt remains same. This is my prompt, and now I'm just going to create a hyperparameter payload. Okay, so hyperparameter payload, and I'm just going to write it payload, and in this payload I'm just going to do this. And the first thing that I'm going to do here is inputs. So my inputs are nothing but the prompt, inputs prompt. Okay, that's the input. Then I have parameters. This is how we define it. So parameters, and these parameters will again be a dictionary. So parameters, and in these parameters we have first thing called do sample. This is a boolean value, by the way. So do sample, and do sample equals to true, not equal. That's basically a key value pair. So do sample, and the next thing is top p 0.7. So here you can also define temperature and all other parameters that are required, guys, right, for getting the response. So temperature for creativeness and randomness, how creative response you want from a language model. That's what temperature does. Okay, so temperature, in this temperature I will keep it very low. It's between 0 and 1. So temperature at 0.3, and just I'm going to write here top k. So in how many responses? So top k, it's again integer, so top k 50, and this I'm going to do maximum new token, which is very crucial here. So Lamini supports maximum number of tokens as 512. That's what I'm going to do here. So maximum number of tokens, maximum new tokens, let's keep it 512, and this I'm going to do here is repetition penalty. So let's have some penalty, repetition penalty, underscore penalty, and this is nothing but the 1.03. So this is my parameter, guys. Okay, so let me just close this. Okay, so I'll just close this parameter, so you can see the payload that we have created. So inputs prompt, and I'm going to just pass parameters into it. Okay, now the payload has been defined. Now let's send request to the endpoint, and our response. So response equals predictor dot predict. This is the class that we have used on top, and you can see I'm just going to pass my payload here, and in that I'm just going to do print response. And now what we are doing here, so we are defining a payload, inputs, prompt, and parameters, and then sending it to predictor dot predict, and let's wait for it. It says expected after parameters. Okay, this will be this. And now what it will do, guys, it will connect with your, and you can see the response, how fast it is, guys, right? And you can also see the previous response, we have a same query, write a short article on blockchain, and here we have write a short article on blockchain, but here we are getting a very good response. You can see blockchain is a decentralized digital ledger that records transaction in a secure and transparent manner. Till here it was, you can see, right? But now once we have the payload, define the parameters, now you can see the beautiful response that we are getting. It is a decentralized system that uses cryptography to secure and verify transactions. Blockchain technology has the potential to revolutionize various industries, blah blah blah. Now we have got it. What next, guys? This is what, at least we have basically reached the first stage. So now let's define endpoint here. Basically the endpoint that we have, we'll just pull it from here. So come here, this is your endpoint name. So we'll just click on this, and we'll just take this endpoint. So let me just copy this endpoint. I'll just come here, I'll just paste. This is our endpoint. Okay, and then the endpoint name here. And now I'll also bring import boto3. So import boto3, and now we are going to inference it on the endpoint. Okay, so import boto3, and we're going to use basically invoke underscore endpoint, which is it's a SageMaker class, runtime dot invoke underscore endpoint. That's what we're gonna use here. So import boto3. Let's have a runtime. This is boto3 dot client. So boto3 dot client, client, and in this client boto3 dot client, we're gonna pass runtime dot SageMaker. So runtime dot SageMaker, that okay, our client is SageMaker runtime. This is our runtime, and now next is response. So let's do a response, and in response is runtime dot invoke endpoint. You can see IntelliSense is able to capture it. Invoke endpoint. I'm just gonna pass my endpoint name. So endpoint and name, and this endpoint name is nothing but the endpoint that I have. Here you can see endpoint, and then we have content type, which will pass it as application JSON, because we are doing a get request here. Maybe you can also, if you are trying to work with post request and you are trying to send data which are bigger in size, maybe you can also explore multi-part, in that case. Okay, so as a content type. So but you have to see that if that supports. Okay, so application slash JSON. Okay, this is my content type. In content type, and now we have the body. So in this body, I'm gonna pass JSON dot dumps. All the payloads would be dumps, and here gonna pass payload. Okay, now this is what we are doing here, guys. Okay, in this endpoint name body JSON dumps. Okay, let's do that. Now you can see it's getting the response. Okay, and now what I'm going to do here, I'm just going to print the response. It will give me, of course, it will give me a generated response, but it will have metadata and all that. I don't need it. We will basically, you can see the response metadata. We have a body right there. Okay, so we have a body, you can see. So let's get that body. So what I'm going to do here, I'm going to have something called prediction. In prediction, let's do JSON.loads, and in this JSON.loads we'll have response, and then we have our body. This is what we have to retrieve. So JSON body, and then we'll have read function. So read, which is a Python function, read, and then decode UTF-8. Okay, so UTF-8, it's basically not caps. Okay, UTF-8, and that's it. So you can see, and now let's just do a prediction. So I'm just going to do prediction here, and again you can see that it's a JSON response. So what I'm going to do here in this case, let's do that prediction. The first one, which will be 0, and the generated text, generated underscore text, and this will be like this. And let's try it out, guys. It says, sorry, this is not how it works. Okay, now you can see that response that we got. So now you can see how fast it is, because we have a decent enough machine, and this is really going to help you guys that how we can deploy, how we can take a language model or a large language model on SageMaker, how we can deploy it with DLC, Amazon SageMaker DLC, that is basically built for Hugging Face models. The models which are on Hugging Face, it supports around 10 to 15 base model, and of course their variants as well. And now you can see that how we are basically automatically deploying it and getting an endpoint, and we are inferencing with that endpoint using invoke underscore endpoint. Okay, now this is one thing. This is on SageMaker. Okay, how we will get the API endpoint, how we can test it in Lambda. Let's do that, guys. So what I'm going to do here in this case is, now I'm just going to go on Lambda here. So come over here. So you can already see this is our endpoint. This is completely fine. Let's keep it as it is. Now come here, and you can already see something called Lambda. So I'm just going to do a right click and open Lambda here. Lambda is a serverless compute service. Okay, it's completely serverless. It helps you trigger events. Okay, so you have multiple events. For example, when we go on e-commerce website, we have shopping carts, right? So when we add something in the shopping cart, some object, some goods, that's basically can be called as triggering an event. Okay, you're putting some objects in the shopping cart. So Lambda is basically a serverless compute service, very very intuitive to understand, and basically it has some timeout limitations, and that we'll see how we can handle it. Okay, so you can see, let's lets you run code without thinking about servers as it's serverless. So let's create a function, guys. So I'm going to create a function. So in this function, what I'm going to do here, I'm just going to write something like, generate data, okay, or generate response. So this is our Lambda function name, and I'm going to use Python 3.10. That's what I'm more comfortable with. Let me excuse me. Let me see if I can use an existing role. No item. Okay, so let's create a new role with basic Lambda presentation, something like this. Let's see. Change default. Let's see that if we get any error here. So author from scratch, function name, runtime, and we are creating a function there. So let's see that. You can also, okay, so now you can see, right, this is a function overview. We have a generate response. You can add layer, you can add trigger, as I said, right, you can trigger it. So this is what you can do here basically. Now if you see, we have a few things over here. The first thing that we have is a test, some code snippet, and we'll Lambda handler that basically handles that trigger. And then we have environmental variable that's not required. Okay, so let's now write some code here, guys. To do implement, you can see that here we have to write some code. The first thing that we're gonna do here, we're gonna bring bot03 because we need a client there, Python client, so bot03. And now I'm just gonna use an endpoint name here, guys. So let me just come back on this SageMaker, and in this SageMaker, I'm just gonna copy this endpoint. So let's copy this endpoint, and in this where we are, excuse me, here, yeah. So endpoint. So this endpoint, we are basically, it's a global, so we are defining it outside the function endpoint. Let's also have runtime global. So runtime, bot03.client, bot03.client, and I'm just going to do runtime.sagemaker here, runtime.sagemaker. Now we have imported the libraries, defined the endpoint and the runtime. We have a Lambda handler here which has event and context. Now what I'm going to do here is, let's have, after this, let me just write query params. What is going to be our parameters? So query params will nothing but the event, and inside this we'll have a query string parameter. So query string parameters. Okay, this is what query params is. Query string parameters as query params. So the query params variable now contains a dictionary of the query parameter with this. So query params, event query string parameters. This looks nice. Now let's specify the query parameters, guys. Okay, so what I'm going to do here is query equals, so the query equals nothing but the query params dot get. So query params dot get, and in this get nothing but a query. Okay, this looks nice, excuse me. And here I'm just going to write the payload. So can I just copy the payload from there? Okay, so let me just come back and take this entire payload thingy. Okay, so the payload, let me just copy this and come back on the Lambda here. Okay, you can see now we have taken this payload, inputs, everything looks nice, and this will not be prompt now, this should be query, because we are taking the query as an input, and query, and then we have parameters and blah blah blah. And now after this, what I'm going to do here is, let's do one thing. Let me just query input parameters, excuse me. Okay, now let's here write this looks okay. Yeah, so now what I'm going to write here is the response. So let's copy that right from there, guys. So I'm just going to come here and copy this entire thing, runtime, and just paste it over here. So this is done. Response, let's also get the prediction. So this is prediction, and prediction is also done. And now the final result. So let's have a final result kind of a thing. So final result is nothing but the prediction and generated text. This is our final result, and I'm just gonna use this final result, prediction 0 generated text. And now what I'm gonna do here is, so we have a return, you can see return status code 200. This looks nice. This will not be hello from Lambda in body, So let me just remove this JSON, excuse me. So this will be JSON dumps, and we're gonna just dump the final result. Okay, so the final result. Now let me just see it once. So we have imported endpoint runtime a Lambda handler, and we are using that in query parameter. So this is what the code for Lambda function, guys. Okay, now what we have to do, we can test it out. Now if you come back here in this not in environment variable, let me just do what's in configuration. We'll look at the function URL later. Create new event. This is okay. And let's see on code. So it's loading new function. Now what we have to do, we have to deploy it, guys. Okay, so we'll deploy this. So now let's test this out, guys, right? So if you see this, let me first save it. Automatically saves, but you have a test here. So we'll create a new event. So let's call this, generate test response. So okay, generate test response. This will be private, and where we have to define, okay, the template right there. Okay, so let's do that. So what I'm gonna do here is, okay, let me just first write, so what we will do, let's have, okay, inside this an HTTP method. So this HTTP method will nothing but this will be get in our case. So let me just do a get, and the next is HTTP method is okay, and the next is the path. Maybe we can have path. So this path is nothing but let's keep this as an example, because we're just testing it out if this Lambda function is able to generate the response that we are looking at after putting the prompt. So path as an example, and now here we will have our query string parameter, guys. Okay, so query string parameters. So this becomes query string parameters, and in this query string parameters, inside this what we're gonna write here is query string parameters, the query. So let's define the query. So our query is nothing but, what was the query? Write a short article on blockchain. Okay, this is our query, okay, on blockchain. Okay, this is the thing. You can also click on format JSON. What it will do, it will format the JSON for you. Okay, now what we can do, we can save this, and let's see if you can test it out. Cool, we tested it out. Okay, and its status code is 200, which is okay. Now this looks fine. Okay, now let's go to code, and we come back to code, and this is fine. This is okay. Now we have a Lambda function here. You can see runtime invoke unit. Let's deploy this. You can say successfully updated the function generate response, guys. Okay, so we have successfully basically generate the response. Okay, now function generate response. Okay, now what we're gonna do here is inputs query JSON dot final result, a status code. This is okay. Now click on test. It says an error occurred when calling the invoke endpoint operation, not authorized to perform error type. Let me see that, guys, why I'm getting this error. So I figured it out, guys. The error was basically due to policies. So we have to create a policy. You can see now I've created a policies for accessing that SageMaker endpoint. And now if you run this, on execution result, let me just run this again, test. Now when you test, it says execution started, but after 3 seconds it gives you an error message, right, that the task timed out after 3.01 seconds. It means if you go on the code, let me just go to code, this Lambda function basically has a timeout issues. Okay, so when you go on configuration, you can see in general configuration we have timeout of 0 minute 3 seconds. So let's edit this. Can we call it 5 minutes? Call this 0 and see if this works. And now you can see our timeout has been changed from 3 seconds to 5 minutes. Now it can access that endpoint and retrieve the response for you. Okay, so what I'm going to do here in code again, come on code, and on Lambda function, let me just do deploy once. Okay, now once you deploy it, test. Now what are you doing here is, you can see now we are getting a response, and you can see the body response. Blockchain is a decentralized digital ledger that records transactions in a secure and transparent manner. It is a decentralized system, and you can just read out, right, complete response that we got through this Lambda function. So now we have created a Lambda function. You can see the function overview, generate response, and we have a configuration here. Okay. Now if you see this function URL, let's see if what happens with the function URL, guys. Okay, so it says no function URL is configured, because if you go and create an API endpoint, that might API endpoint also has an issue. So let me just do one thing what I'm talking about. Let me search here API endpoint, or API gateway, sorry. API gateway. When I click on API gateway, if you come over here, let me just see. So you have an HTTP API, for example. Let's create on build for now. Let's see what we get. Okay, API name. So what API name you want to give? So for example, let's call it generate response. Click on next. Default is okay. Something like this will create. Now when you create this API gateway, the problem with this is that it kind of times out after 30 seconds. Okay, that's a problem. Okay, so we are not going to currently, maybe we can create that, but not in this video. But my focus is, if you come here on function URL, you have something called create function URL. Okay, now let's see what we get on creating function URL. So let's call it none, for example, and see additional settings. Buffered is okay. And what if I do configure star asterisk would be there. This looks nice. Now let's see if we can create this function URL. Lambda won't perform IAM authentication, that is okay. Let's see what we get. Now you can see it says your function URL is public. The good thing about function URL is that it has, I think it has a timeout limit more than 30 seconds. Okay, I think API gateway has a hard limit of 30 seconds. I think it's by 29 seconds by default to get a response. And most of the time when you are working with a large language model, you might not get that response in 29 seconds. When you are using 30B or 40B models, it might take more time. Okay, even on a consumer GPU or a single GPU, for example. Okay, in this case. So can we look at function URL and see if that works? So let me just do one thing. Okay, I'll just do a open link, and currently it says internal server error, and let's see that. So I'm just gonna call generate, or what we're gonna do here. Are we gonna pass here the query, or let's see. Okay, so query, and write an article on blockchain. I don't know why I got server error, but let me just come over here. Changes have been saved. Function URL. Okay, buffered. But maybe we can check that out, guys, later. Okay, so the whole idea was to deploy a model, and you can see we got a response. Okay, blockchain is a decentralized digital ledger. It's so fast also. The function, it works same way that in Azure we have Azure functions. Okay, and we have in AWS this function URL, right? So you can use this function URL in your Streamlit application or any other application. Any other, you can create an UI and use that, right, from backend. Okay, so this is, you can see, right, how we are getting these responses from the function URL. Just pass query, and let's try some other query as well. Okay, for example, write an article on AI, something like this. Okay, so now when I hit this, okay, it should basically fetch the response for me, and you can see how fast it is. AI is a rapidly growing field that involves and something. So we got our response through function URL. Maybe you can, of course, you can create API gateway, configure it, invoke the Lambda through an API gateway. You can of course do that. No, I'm not doing that in case. Okay, just two steps. So I like function URL in that case, guys. Okay, so now you'll know that how we can take a language model from Hugging Face, and you can deploy it through DLC, using this Hugging Face LLM image URI. You can deploy it, you will get an endpoint. Automatically your endpoint will be created over here. You can see this is the endpoint that we have created. Now once we have an endpoint, we go on and create a Lambda function here, generate response. And when you're creating it, make sure you have all the policies in line. Okay, we have all the policies given, the access, and then we create a function URL out of it. And your function URL, you can see, and you can again add authentication here if you want, but for now I haven't done this any authentication here in this. So this is what I wanted to do in this video, guys, that how you can deploy large language model on AWS. Okay, and this is the completely on a model part. Okay, maybe in the next video we can see that how we can create a simple application using this function URL, the function that we have created. And now you can see, right, how easy it is to use the SageMaker or the DLC there, basically to deploy Hugging Face models. Now you can deploy models by your own. Please go ahead and deploy a few models and let me know your findings and insights of these services. Okay, so this is what I wanted to do for you, so you can you can create an account on AWS. The entire exercise will not cost you more than $2 or $3, guys, to be honest. Okay, just go ahead and try it out and see if you can deploy it, because at your workplace you have to work with some hyperscalers, right? That can be AWS, GCP, or Azure itself. Okay, so I hope you liked the video. Okay, if you have any thoughts or feedback, please drop that in the comment box, and you can reach out to me through my social channels. And I'm also creating a community on WhatsApp and Discord. Please reach out to that community as well, and you can join that community. You will find the WhatsApp link in the YouTube banner. And I hope you like this. Okay, most of the code will be available on the GitHub repositories. Okay, that's all for this video, guys. Okay, thank you so much for watching. See you in the next one.